Welcome back to Machinist Made. Today we're going to go over the Titan 6M. I do my 6M a little bit different than a lot of people do theirs, mostly being from the fact that I like to break my operations up a little more in depth. So like always in Fusion 360 in the manufacturing tab, we're going to start off with a setup. Setup's located right here. Within that setup, we always want to make sure that our Z is pointed straight up and that our material is the right size. Again, we don't work in relative. I know what size my material is going to be. It's going to be a 2x2x1 block. My model position needs to be offset from top. And my offset amount is a mere 20 thousandths. That's all the material I want to take off. Aside from that, I'm going to go to post process. And I'm going to change this to 6001. I'm also going to change program comment to Titan 6M. And my work coordinate is going to be G54. Under the new update that they just did, our machine work coordinate system, it says format standard, work coordinate system G54. I like this much better than they had on the previous version. Once we've done this, we're going to simply click OK. Now, I have a machine automatically turned on. To get rid of that, I'm just going to turn it off with a little eyeball right here. Now, the first thing that I'm going to do is your standard face pass. The tool that I'm going to use is Tool 1, which is a 2-inch face mill. This can be found under milling tools, face mill. There's your 2-inch face mill right there. I'm going to be using all standard tooling provided by the Fusion 360 library. So I'm going to select our 2-inch face mill. I'm going to use the stock feeds and speeds that are in here. You need to adjust those based on what kind of machine you're on. But I am on a Haas VF2, which will run these absolutely no problem. I'm actually going to make a slight adjustment to the RPM at 4,500. I know some people are probably thinking, wow, that's high, but it's honestly not. 120 inches a minute. And that's pretty it. I don't really need a very fine finish on this face. 5 thousandths chip load at 20 thousandths depth of cut. My machine's not even going to know it was there. It's going to sound like a buzz saw went across it. Now outside of that, I'm just going to click OK. I don't need to make any modification or changes to the tool or the standard toolpath Fusion is going to kick out. The next thing that I'm going to do is I'm going to clear a lot of material, so I'm simply going to go to adaptive clearing. The tool that I'm going to use is a 3/8 end mill. So again, under milling tools, flat end mill, 3/8 end mill. And I'm actually going to come down here and pick the feeds and speeds that I'm going to run at. I'm going to run at aluminum roughing. I'm going to mash select. And it's going to infill all these feeds and speeds in for me just fine. The next thing that I'm going to do is go over to the passes tab. My optimum load, I'm going to change this to 75 thousandths. I have found for what I'm doing, this works pretty optimally. Stock to leave, I'm going to change this to 10 thousandths, and you'll see axial changes when we change radial. I will turn smoothing on, and I will change this to 1 thousandths. The reason being is the machine that I'm on does not have high-speed machining. So I need to change my high-speed machining toolpath to be a little bit smoother. Next thing I'm going to change is under linking. Instead of full retract, I want my milling head to stay down to the very minimum. And then I'm also going to change most under stay down level. I want to stay down as close as I can. I'm going to change my lift height to only 5 thousandths. And that is it. Once I get all my parameters in, I'm simply going to click OK. I didn't select a pocket. Look at there. So the pocket that I'm going to select is the bottom of the part and the top of the part. Now, one caveat that I need to make note here is you see how these holes are not highlighted. I want to make sure I am highlighting those holes. The reason is, if we don't, it won't cut there, and then we'll end up with a stub. Or used to. They might have changed the update, I don't know. But we're going to make those selections, and we're going to click OK. Now we should see two toolpath, one upper, one lower. We'll have to come back in here and clear this cross section out with a 1/4-inch end mill, which is the next thing that we're going to do. So we're going to come in with 2D contour. The tool I'm going to use is a 1/4-inch flat end mill. So milling tools, flat end mill, 1/4 inch right there. Again, I'm going to come over to aluminum finishing instead of roughing this time. The reason simply being is I want a better surface finish on this right here, and it gives me a little more RPM. Now I'm going to go to my toolpath. I'm going to select the bottom of that square because I got to go all the way down. The next thing I'm going to change is linking. I want a ramp. 2 degrees is fine. It's not going to hurt anything. And then I want to come back over here to passes and make sure that I'm not leaving any material. The reason is the distance between these two lugs are pretty close. I don't want to leave any extra material. There's our toolpath. Now one thing that we need to fix, see where this end mill bit in right here on the entry? We need to change that. So we're going to right click and edit. Go back into linking. And in entry position, we want to enter on the corner of our part, and we want to exit on the corner of our part. And then I want to change all of this information. So I'm simply going to change lead in angle to 5 degrees. Let's see if that gives us the proper clearance. Gives us the proper clearance, and everything looks pretty good there. Okay. Now we need to finish this floor. We need to finish the outside of our part, and we need to come back and finish all of the other remaining lugs as well as drill and tap. The alarm that we're getting is about the lead out can't be reached for the positioning, and that's because we're pulling out. To fix that, we can go back into linking and deselect our exit position, and that alarm should and will go away. Now the next thing that I am going to do, like I talked about before, was the finishing pass. I'm going to use a 2D pocket. Same 1/4 inch end mill. I'm going to select that pocket with, again, all those holes. Now the next thing that we're going to do is go to passes and turn off stock to leave. I'm basically using a roughing pass as a finishing pass. This allows me to get around everything and clean everything up at one time by clicking OK. Notice how it cleaned everything up. Now I will change this helix right here because honestly and truly I just forgot. So in linking, we'll change our ramp style to plunge and click OK. Now we're going to plunge straight down. Remember, there's only 10 thousandths left on the floor. It's not going to hurt that end mill. Next thing that we need to do is finish the outside of this part. 2D contour. I'm not going to use a 1/4 inch. I am going to use the 3/8 we used previously. Oh, that was tool 10. And what I will do is I will actually move this tool up later so we're not changing tools repetitively to tools we've already used. The geometry we're going to select is the bottom, and we just have to click OK. The software knows where the part's at. No harm, no foul. Now I can pick this up, hold with my left mouse button and drag up, and I can move that to a different position. And now the next thing that we need to do is drill and tap. We're going to drill these 4 holes. We're going to drill these holes, and then we're going to tap them. So we're going to start out by drill. The tool that we're going to use, I believe, is a 1/4 inch or an E letter drill. So we're going to go to hole making tools. We're going to select drill. Then you can sort through all this if you want, but since we know what diameter we need, we're going to go diameter equal 0.250. Hit enter, and then we get our 1/4 inch and our letter E drill. Keep in mind, in the machining world, these are the exact same tool. I'm going to select my 1/4 inch drill, select, go to my geometry. I'm going to select those 4 cylinders, and I want you to take note, it doesn't go all the way through. So now we need to fix that. We go to heights, and then we just have to click one little box, drill through, and there we go. We've done that, we can just simply click OK. There's nothing fancy here to do. The next thing we're going to do is another drill. These drill and tapped holes are 1032, which makes the drill size for a cut thread 159. So drill, again, diameter equal to 0.159. Enter. That's a number 21. Select on that drill, select OK. And then you'll notice in Fusion, you can't actually click on the wall of the circle like you can here. So we have to use the bottom. Then we'll make some adjustment to our heights to allow us to use that. So right now, you see, it's only wanting to drill the very point. The way we change that is we go to heights for one, and we do the drill through because we do need to drill deeper than the hole indicates. And then our feed height. It's not top height, it's model top. And then top height, model top. That allows that hole to extend all the way up. Once we've done that, we can simply click OK. And because I'm lazy and I don't feel like duplicating by clicking all the buttons over again, one shortcut I have learned is to right click on the process you created, duplicate, creates it right here, right click and edit, and then change our tool. We can go to hole making, we can go to a right hand tap, and then we can find our 1032, which is right here. Click on there and it will automatically change our cycle from drilling to tapping. The only thing we need to change is over in heights, is we don't want this to drill through because we want our tap to stop short of the bottom of our hole. That's how you intuitively create a crash, intentionally or unintentionally. Next thing we need to do is double check our RPM. 500 RPM, plenty fast enough, plenty slow enough. So once I've done this, I'm selecting OK. And then there is your part. Op 1 completely done. I'm going to right click and simulate so you can see the part run. This is a little bit more of an intricate part, and I did see something. Did you see that red flash? Let me replay that. We're going to change that. So the face mill comes in, faces the part off, no problem. And then the 3/8 end mill comes down, and oh no, we're hitting the part. Let's change that. Let's exit the simulation. Right click and edit. Then I'm going to go to my geometry, stock contour. See that yellow box that pops up? I am letting the machine know that, hey, I want you to cut there. I want you to cut everything out. See how much wider that toolpath is now? So now, when we go to simulate it, we won't see that crash. See the little yellow area or red area down here is gone? Now we're going to fast forward just a little bit, and when that end mill comes in, see how it comes in off the part? That's what we want. We don't want to slam the end mill down into a part not that deep anyway. If it was 5 or 10 thousandths, we would live with it. But on this part right here, being about 250 thousandths deep, that's not going to do nothing but cause trouble and clog a flute of an end mill up, regardless of whatever coating you're using. So there it is. That is the Titan M6, completely programmed and ready to run on our Haas VF2. If you've got any questions, comments, concerns, please feel free to leave them down at the bottom of the comment section. I'd be glad to answer them. And if you've got any other questions regarding how I program this, again, the comment section is the best place to reach out and get those questions answered. Like always, like and subscribe. Hope to see you back here. There's always great information. Have a good one.